Yes, you can start na.
Ayan. So, yung sample problem dito is galing kay Engineer Rino. So, start na tayo. Simple problem exercise lang naman to kasi usually na-take up na natin to sa ME Lab natin last semester. So, yung sample exercise natin, 800 brake horsepower diesel engine, water 6 cycle, has a brake thermal efficiency of 32% and a jacket water loss of 30%. It uses a closed cooling system with a cooling tower 10 meters high. The temperature rise after passing the water jacket is 15 degrees Celsius and the cooling tower range is 6 degrees Celsius. So yung mga required natin or yung hinahanap is first yung make a sketch of the cooling water system, capacity of the jacket water pump, exhaust in BTU per hour if the radiation and other losses total. So kasama yung mga radiation and other losses. So cooling water flow rate in the cooling tower. And the last one is the standard size electric motor to drive the cooling tower pump. If the total dynamic head is 35 meters and the pump efficiency is 88%. So, syempre sa mga problem, importante list daw natin yung given as well as yung required. So, ito yung mga parts na yun. Ayan. So, ito yung given natin and then ito yung mga required natin na kailangan natin hanapin. So, first, sketch muna natin yung cooling water system. So, ito yung typical na setup ng cooling water system, kagaya nga sa pinanood natin kanina. So, kung mag-i-start tayo dito, yung cooling water natin, yung papasok dito sa cooling tower natin is a hot water coming from the jacket section of the engine, diesel engine. So, mainit yung tubig na yun. And then, pupunta yun sa cooling tower natin para palamigin. And then, yung mga condensate or yung mga babagsak na water is, of course, malamig na. So, ngayon, papasok yun sa pump natin para ipasok dito sa heat exchanger natin, papunta sa pump natin. Ay, papunta sa diesel engine natin. Since cold water ito, so siya ngayon yung magpapalamig doon sa diesel engine natin kasi we're trying to avoid overheating of the diesel engine or yung diesel generator natin. Kasi it would pose accidents or risk doon sa diesel generator natin. So, pwede siyang masira kapag nag-overheat siya. So, yun yung ina-avoid natin. Kaya nag-i-install tayo ng cooling water system para sa diesel generator natin. And then, yung mga lalabas doon, yung mga nagamit na cooling water natin, babalik sa heat exchanger natin, papunta doon sa cooling tower natin para palamigin. So, yun yung typical cycle natin when it comes to the cooling water system. So, for the capacity of the water jacket pump, so ang una natin kailangan gawin is to solve for the mass of water jacket pump. So meron tayong conversion factor na for every 1 brake horsepower, meron tayong 2,545 BTU per hour. And then ito yung percent of the losses sa jacket water pump natin divided by the brake efficiency, the specific heat of water, and the temperature of the water. So, multiply natin yung given na brake horsepower which is 800, convert natin into BTU per hour. Multiply natin yung value ng jacket natin, losses is 30% which is 0.30. Ang brake thermal efficiency natin is 0.32 or 32%. And ang specific heat of water in English units is BTU per pound degrees Fahrenheit. So, multiply lang natin siya by the given which is yung 15 degrees natin. Wait lang. So, 60 degrees yung 15 degrees Celsius convert natin into degrees Fahrenheit. So, cancel yung Fahrenheit natin and then cancel din yung BTU natin sa taas. So, ang matitira sa atin is pound per hour. So, the mass of jacket water pump is 31,812.5. Pero ang hinahanap natin is capacity of the water jacket pump which means the volume. So, gamitin lang natin yung formula natin for density, which is density is equal to mass over volume, and then kunin natin yung formula for the volume of the jacket water, which is simply the mass of the jacket water divided by the density of the water. So, yung density natin ng water in terms of pound per gallon is 8.33. So, divide lang natin siya. 31,812.5 pounds per hour divided by 8.33 pounds per gallon. So, since GPM yung hinahanap natin, convert natin yung R into minutes. So, multiply lang tayo ng factor dito, conversion factor of 1/60. So makukuha natin yung jacket, yung volume or yung capacity ng water jacket pump, which is 63.65 GPM. So the next one would be the generator exhaust loss. So ang gagamitin naman natin dito is simply the energy balance. Mass in is energy in is equal to energy out. So meron tayong pumasok na 100%. Ang given natin na jacket water losses is 30%. And ang nagamit lang natin doon sa 100% sa thermal efficiency is 32%. So ang radiation and other losses natin is 8%. So, ang hinahanap natin ngayon is yung percent ng generator, yung losses sa generator. So, it is simply yung mass in natin, 100%, plus yung mass out, 30% for the jacket water loss, 32% for the brake thermal efficiency, 8% for the radiation and other losses, and then yung hinahanap natin. So, compute mo lang to. So, ito 30 plus 32, which is 62 plus 8, 70. 100 minus 70 is 30%. So, ito yung generator exhaust loss natin. Ay, yung percent pala. Yung percent generator exhaust loss natin. So, to compute for the value of the generator exhaust loss, ito yung formula na gagamitin natin. Percent of the generator exhaust loss is equal to generator exhaust loss divided by E sub C or yung energy ng cooling tower natin. So, manipulate lang natin yung formula, lalabas yung itong equation, and then itong E sub C na to is given na siya. Direct substitution lang tayo. Convert natin yung 800 horsepower ulit into BTU per hour, and then multiply natin yun by the percent of generator exhaust loss, which is 30%, divided by the brake thermal efficiency. So, ang makukuha natin ngayon na generator exhaust loss is 1,908,750 BTU per hour. So, ito yung generator exhaust loss natin. So, the next one would be the capacity for the cooling tower pump. So, again, use lang natin yung energy balance natin. Yung energy in is equal to energy out. Yung water jacket energy natin is equal to the cooling tower energy. So, ano ba yung mga components ng water jacket energy natin? It is simply the mass of the jacket water multiplied by the specific heat of water times yung temperature difference na given kanina para sa jacket water. And the same with the cooling tower. So, mass ng water para sa cooling tower, specific heat of water, and the thermal change in temperature or temperature difference para sa cooling tower natin. So, since same naman yung value ng specific heat of water natin, cancel na lang natin itong dalawa. So, ang matitira sa atin is the mass of jacket water multiplied by the thermal difference for jacket water, and same din sa kabilang side. So, substitute lang natin yung values, i-manipulate natin, isolate natin itong mass ng water para sa cooling tower. So, ito yung lalabas na formula natin. So, multiply lang natin 31,812.5 pounds per hour multiplied by 15 degrees Celsius divided by 6 degrees Celsius. So, cancel yung Celsius natin, ang matitira is pound per hour. So, ang mass natin ngayon for the cooling tower would be 79,531.25 pounds per hour. Pero ang hinahanap ulit dito is capacity, so kailangan ulit natin gamitin yung formula kanina, which is volume is equal to the mass over density. So, ito yung kanina. So, same lang naman ang process. Divide natin by the density, which is 8.33 pounds per gallon. So, ang lalabas natin is gallons per hour. Need natin i-convert into minutes. So, that would be 159.13 GPM. Pero cubic meter per hour yung gagamitin natin kasi sa next requirement natin, kailangan natin hanapin yung brake power ng pump. So, convert lang natin siya. For every 1 GPM, meron tayong 0.227 cubic meter per hour. So, ang total volume natin ngayon, or ang capacity ng cooling tower pump natin, is 36.12 cubic meter per hour. So, ito yun. So, the last requirement would be the standard size of cooling tower pump. So, alam naman natin na ang formula for the efficiency ng pump is only equal to the output or yung water power divided by the brake power. So, since brake power yung hinahanap natin, cross-multiply lang natin ito. Yung water power natin would be divided by the efficiency of the pump. And sa fluid machineries natin or fluid mechanics natin, the water power is simply the gamma QH or yung the specific weight ng water natin, which is given by 9.81 kilonewton per cubic meter. Yung capacity natin, which is yung solve natin kanina, 36.12 cubic meter per hour, kailangan lang natin i-convert into 3 seconds. So for every 1 hour, we have 3,600 seconds. And yung total dynamic head natin, which is given kanina doon sa problem, na 35 meters. So, cancel yung cubic meter dito. Meron tayong kilonewton at saka meter, that would be kilojoules, divided by second, which would result to kilowatts. So, yung brake power natin or yung power na kailangan ng cooling tower pump would be equal to 4 kilowatts. So, yun lang po.
Thank you, Bert. Tapos na ba yun? Okay na yun?
Yes po, sir.
Sige.
Yun lang po sa problem natin.
Okay, sige. So, thank you very much no, kay Albert sa niya.
Thank you rin po, sir.
Sa explanation, no. So, yung mga iba pang problem, ibibigay ko na lang, no. May mga presentation din akong ginawa. And then, bibigyan ko rin kayo ng mga parang exercises para yun na lang ang report natin, no, sa lab, no. So, I think for the meantime, yun muna, ipapasa ko na lang yung yung mga ibang presentation na ginawa ko. Tapos, bibigyan ko kayo ng mga exercises. Group na lang, by group para hindi na tayo mahirapan. By group na lang ulit, ha? So, yun muna, pwede na rin kayo mag-leave. Ako na bahala dito sa natin, sa attendance. Kasi may nirarush lang ako sa UE. Salamat.
Thank you, sir. Thank you. Salamat.
Pwede na mag-leave class. Thank you. Ingat kayo.
Thank you, sir.
Thank you. Send ko na lang mamaya yung mga additional presentation ko. Saka yung sample problems na by group.